So welcome back, everybody. Our next speaker is going to talk about going agile with Kanban from the Red Hat JBoss EAP story with Dimitris Andreadis. A big round of applause, guys. And he's going to tell us how their engineering team uses Scrum and got to adopt Kanban. Pros and cons. Thank you.
Thanks. So the talk today is about how my team, a relatively big and established product, got to use Kanban to become more agile. And in the process, I think you will realize that even known products suffer the same way that you guys suffer, in your everyday work. And my name is Dimitris Andreadis. I work for Red Hat. I manage the JBoss EAP team, Wildfly team, and some other stuff. Yesterday, some person actually asked me, "Oh, what's Kanban?" And I thought, "Oh, you don't have to explain everything about Kanban." Unfortunately, there is no time for it, so I put this slide like the last moment. Who's know what is Kanban? Good. Who's using Kanban? Who's using Scrum? Aha. All right. So I won't have much time to talk about what is Kanban. Rather, I talk about what we did with it and why and what we learned. And disclaimer: I'm not an agile coach. Neither a Kanban expert. I just do products. So, while people are still coming, I'm gonna set the stage, explain, what is this that we're working on, what problem we try to solve. I think it's very important to understand, when you try to go agile, what you're trying to achieve. Don't go with a solution to fit your situation, rather try to understand what is your problem. And then how we started with Kanban, and through multiple iterations, by learning from our mistakes, we got to the situation that we are today. And if I have time, I'll show you some of the tooling we created to make Kanban work for us. So let's think a bit, the good days where you had an idea, maybe put something on paper, you went to your computer, turn it on, the basic interpreter comes up, start coding, some errors, coding a little bit more errors, run, it works. That was magic. From conception to a working thing that you totally control, and that's the joy of coding and programming and this great feeling. But then came processes. So we went to study, computer science. We went to work, and then we learned that computers are a serious business. And we have to follow processes. We have to be serious. So we have to analyze the problem, come up with a design, code it, test it, deploy it, fix, maintain, etc. And I worked in the telecoms domain for 7 years using these patterns. And we realized that this kind of works if you cheat. The only way to make the waterfall work was to cheat. So what you do, someone told you, do this. You put your idea on a paper, and then you went and started working on your prototype, going back to enhance your design, write some tests, go back to design, try something different, until you reach the point where you have enough knowledge of your system and your problem that you can kind of guess how much is the remaining work, what is possible to do, and then you go back and say, yeah, sure, I'm going to do it, yeah. And then you go back and even change the requirements to fit the reality. And we got away with it. And while working on, on telecom stuff, I came across this project back in 2001. JBoss was like a new open source project. I was interested into some of the technologies they were using, and I thought, maybe I could use some of this stuff, change it. That was, open source magic. And there I met a different world. There was those people working from their bedrooms mostly, and they would just focus on code. And they had, tests. You write code with tests. There were integration test suites running all the time. And if you break the test suite, someone will shout to you. There were some basic coding standards, nothing very fancy. Minimal documentation, minimal design. Other people looking at your code, very high quality engineers, meritocracy, the best voices would be heard, collaboration. And somehow this dispersed community managed to produce stuff that was really a lot more complex than what I was building in my proprietary life. And I was totally amazed, how they do this. Later, we realized that that was really, extreme programming principles. We were doing this, then we got a name for it, and it was great. And I was doing more and more of this. And at some point, the founder of JBoss was like, this small thing, got funding. They could hire people like me that we were working on their spare time on the project. And we used the Matrix analogy from the movies. You take the blue pill, you forget all about it, you go back to your, ordinary life, or you take the red pill and you enter the Matrix. And things will never be the same again. And guess what choice I made? And I joined the company, and we did tons of releases using this open source model. And we were very successful. And at some point, Red Hat came and said, yeah, I'm going to buy you. Cool. They bought us. And Red Hat had a slightly different model. They were like the leaders of open source, obviously. They had this dual model where you had Fedora, the free Linux, and you had Red Hat Enterprise Linux, which was the product. And we kind of developed both of them, working on the community, working on the product. We split the JBoss application server in two. We produced Wildfly, the community project, JBoss Enterprise Platform, the product. And we did tons of releases. I've seen everything, for the last 15 years. And what was once a small, renegade project became a huge platform. Just to give you some indication, what huge is to me. So JBoss EAP is the second biggest product of Red Hat in terms of revenue. We integrate something like 150 different components or projects. A project can be as small like a logging library to a messaging service and transaction manager, JPA provider, clustering infrastructure, something very complex. So 1/3 of those projects we actually build ourselves. So 50 projects are owned by my team. We deliver in multiple ways. So we have zips, we have RPMs, installer, container images. We productize quick start, Maven repository, source code, docs, blah, 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 too much stuff. And we have multiple release streams that we support. Version 4 is deprecated. There's version 5, version 6, version 7. Different teams doing some of that stuff, the core team working on the next features. And we do that on 4 JDKs, 8 operating systems, 4 chipset architectures, 19 database combinations. So do the math to see how big is our testing matrix. So to run a full test suite of everything on a massively parallelized infrastructure, it takes 2 weeks. And we test for performance, interoperability, compliance, regression, certification, security, so on and so forth. And we do this with a team that is very much distributed. My team is spread in 15 countries, 21 native languages. So that's what we have to work with. And let's see at the problem. So I'll go back to EAP release 7. It was a very big release. And the way that things worked in Red Hat were pretty much waterfall, right? So there was some sort of planning phase where we decide engineering, product management, and quality assurance. They go together and they give the 3 acts. They have to agree, yes, we're going to do this feature in the next release. We do the work, we test, yeah, we release, in theory. There's a series of builds. So every 2 to 3 weeks, we cut a release. And it can be either like alpha quality, developer build, beta quality, maybe to give out to customers to try out, release candidate, a possible final release. And then we have the situation where we might still develop a minor release stream. So let's say EAP 6.1, 6.2, 6.3. And at the same time, we work on the next major version, so EAP 7. So those can run in parallel. Now, what was wrong with this is due to this dual minor-major cycle, you might end up with very long cycles for the major version. So it could be 3 years. And in EAP 7, we had this ridiculous situation where the planning phase was open for 14 months. So essentially what happened was the product management came initially with a set of specifications. And of course, within 14 months, things changed. So they came back and said, hey, now I want this as well. And this as well. Can you recalculate? And this. And maybe if we remove this, we can add this. And then every time we have to go back and replan. And it was horrible. Problem with requirements, you probably have the same. In the open source world, things are kind of simple because someone comes with an implementation, and that's great. You don't need the requirements. They reply to some problem. You have the solution. There you go. When you work the other way around, someone has to tell you, hey, we have to do this. And quite often, the definition is very vague. So that was a problem we had as well with product managers that came to our team that came from the proprietary world. So they didn't really understand how open source works. And then with having all that in mind, sticking to a release date was pretty much impossible. And I had this golden rule of 7, which the rule was, the moment you think you are done, you need 7 more builds to finish. And somehow the rule verified every single time. It was a heuristic. I have no clue why it's true, but every time someone will tell me, oh, we're going to be finished, I was laughing. I knew, 7 builds. And then, when you have a project that's very much advertised within the company, everyone has an opinion. Everyone knows what's best for the project, except for the people that actually work for the project. And of course, at that point, the pointy hair boss comes with a solution. We have to go agile, right? And when the boss says we have to go agile, you know what that means, right? You have to use Scrum. Yes, you have to use Scrum. Why Scrum? Because everyone's doing Scrum. So yeah, I sat down and I was thinking, looking into Scrum. Can we fit our team with Scrum? And there were many teams in Red Hat that were doing Scrum. They went through the pain, and I talked with many of them, trying to understand, if we can do the same. And my number one problem was, let's say, resourcing. So Scrum requires product owners per Scrum team. So I was thinking I probably need to organize 6, 7 Scrum teams for EAP. And everyone needs to have a product owner. There was no way to clone the product manager. It was just one. So most probably we'd have to be the product owners ourselves. And then I needed Scrum Masters. So we'll have to train some engineers to rotate as Scrum Masters. And then we probably need a Scrum of Scrums to run the whole thing. So maybe another 10 people to adopt Scrum. And at that point, I knew, there's no way to get 10 people just to say, we go Agile. So that was for me like a showstopper. Then, this team is very distributed, 15 countries. There are specialized pockets of excellence. 2 guys, they know everything about clustering. 2 guys work on EJBs. Another guy knows about Corba. They don't even have to talk to each other quite often. They're different teams. And many of them are veterans. They worked on this forever. And I'm going to tell them, you have to go in a stand-up meeting with this other guy on the other side of and just tell every day what you're doing. There will be a revolution. And typically, the features we develop are long. So we're talking about a couple of months for something to be demonstratable. So it's not always obvious how to break it into small pieces. And what problems I was actually trying to solve? So I wanted to reduce planning. That was my big thing. Ideally, I would eliminate planning. I wanted to reduce context switching because every once in a while someone would come and say, oh, I want you. You have to work on this, and it's super urgent. And my developers are good guys, so normally they say, yes, I'll do this. And they would often overcommit, and then, of course, when they could not deliver, things would go bad. And we had to improve requirements. Quite often you discover that that's not really what they've asked for, and you find out at the end of the cycle, when you do your testing and everything breaks, and then you have to go back and refactor. That was a big problem for us. And some way to provide enhanced visibility, especially with those open source projects, it's not obvious. What's the state of the project? It's a bit chaotic. So again, going to the Scrum versus Kanban question, to my simplified brain, Scrum looks like this. I have a set of stuff to do. I have finite resources. And I try to understand how, by breaking the problem into pieces, how I will fit those tasks into my finite resources and iterate into this unit of time, which is my sprint. And by becoming better in my planning, I should be able to predict more precisely how big or small, how much I can manage within the sprint cycle and optimize this. And by running those very tight loops where everyone sits together and every day and they say, I'm working on this, I have this problem, you identify problems fast and you can solve them fast. So that's like in one sentence, let's say, what Scrum was in my mind. But I was always thinking about this planning fallacy. I think people overestimate their abilities to understand complexity and what's coming. So my thesis is that for every truly complex system, you just have no clue, what's going to happen after a couple of sprints. And case in point, you do a big refactoring. You have a large code base. You start from point A, you go to point X. You don't know where is X. You don't even know what is involved in X. You have some desire to refactor. And it's once off. There will never be the same refactoring again. And we had a situation like this in EAP 7.1. We replaced the security infrastructure in the server. It was a huge project. And we tried really hard to break it into pieces. We identified more than 100 tasks. We tried to, estimate again and again. And we failed miserably. Any prediction we made was wrong. There's no way to predict what will happen after 17 sprints. Yeah? And then when you reach the end of the road, you have to deliver, and stuff is broken. So what you do then? in my view, when you have a serious system, when it comes to correctness versus time, correctness wins. So rather than spending your time estimated when you'd be done, maybe you just work on the problem and solve it. So for me, planning in this type of problems is a waste of time, and I very much prefer an asynchronous style where I have my people, good people work on the tasks, prioritized, and they pull work. And as if you have an asynchronous messaging system that self-balances itself, the same way you balance the work and you have, optimum throughput. You can even do, more advanced stuff when you have this working well. You can estimate how much time between a message enters the queue and then exits the queue, and maybe you can make some projections, but I don't want to pretend that I'm that smart. So that was my idea when we were trying to understand what to do to become more agile. And Kanban seemed particularly interesting because it's a true pull processing model. And it has some unique features that to me look very attractive. So you can bolt Kanban onto your existing process. You don't have to change the process initially. And thus respecting the team roles and the team dynamics that have developed over time. It takes less resources to implement. For this whole project, I had one guy. I had one guy to be my process master. Right? I didn't need 10 guys to agilify my team. And Kanban forces you to think about the way you work. Not about the process, but how you actually work. You have to analyze your states, your inputs, outputs, handoff points, definitions of done. And that's not always obvious. When you try to apply this to your system, you'll realize there's a lot of stuff that's not documented. It's tribal knowledge. Depends on who handles an issue. Some guy will do it like this, another guy will do it different. Then Kanban helps you visualize work. So you can tell those guys, you want to see the status, check the board. And this idea that you start, that you iterate, and you improve your process. So those were very, attractive aspects of Kanban. So our goal was to get rid of planning, improve on what is to be implemented. We introduced some sort of analysis phase where developer, product management, and QE would iterate over some document in any form. We didn't care about the form, to agree that we have a requirement that is useful enough to be able to implement it. We wanted to involve Q quality assurance earlier in the process and not at the end. Encourage developers to write more docs and make it all more visible to upper management or whoever wanted to check status. And maybe try to see if we could work with the Timeboxed model at some point. Now, when people think about Kanban, this picture comes to mind. Kanban is easy, right? To do, doing, done. Yeah, end of story. Well, reality can be deceiving because when we first try to see, okay, what are our states? Those are not 3 states. Those are 23 states. We just group them. And with the exception of the analysis phase that we introduced to solve this problem, to have more clear requirements, and some buffer points where one team would hand off to the other, so development to productization, to do the source builds, and productization to quality assurance. So everyone pulls the work, and it's not pushed to them. That was the situation we faced when we started with Kanban, which was a bit revealing, but 10 minutes. I think I have till 10 minutes past, no?
For a
Okay. So, yeah. So the number of states is a problem, and the other problem is Kanban is very sequential. So how you model concurrent tasks? A single workflow cannot work for everyone, and then tool support was very poor when we looked at it. It was impossible to visualize a very complex system with the tools that we're using. We're using Jira. So when we started doing Kanban, then we thought we really need some way to model parallel work. So we came up with this idea that we have parallel tasks, and those tasks would have their own state. So like upstream commits, downstream work, test development, community docs, they could all proceed in parallel. And we came up with those colored boxes to indicate progress in those areas. So then we managed to cut down a bit the states, about 1/3. That was a first good step. And when we finished with this first utilization of Kanban, we saw that planning went smoother. Analysis phase really helped. People could see the status of the project. Parallel tasks really helped to model reality. And in many cases, test development happened earlier. So in this regard, it was successful. Some problems, still the development time was small relative to the other phases, which we didn't like. Once you merge something, you have to fix it. There's no easy way out. Testing still happened late for some of the features, and some people took the process too literally. Some developers, especially in quality assurance, they were insisting, this is missing. I won't pull unless. So then we have to make more changes, and there was an interesting new requirement that came to us and required that we somehow deliver EAP in a faster cadence for cloud use cases, for OpenShift specifically, for our cloud offering. And the goal was to bring a process that was often taking something like 18 months down to 3. So 18 down to 3, 6 times reduction, huge difference. And it would look something like this. So we have the community project in blue. We would time box to 3 months. Every 3 months, we productize this into EAP CD, EAP continuous delivery, and repeat the cycle for those that want to develop in the cloud fast. Every 3rd or 4th release would become a traditional bare metal release with a long support cycle. So community projects switched to time boxing, and to make this possible, we switched to feature branching. So everything is developed on special branches with teams that are assembled dynamically. So developer comes together with quality assurance, comes together with a doc person, and they work. And they do stuff in isolation, and they have to complete all requirements before they're able to merge back to the main line. So they need to have some sort of analysis, the code, all the code documented, test plan in place, basic tests and regression tests with the remaining part of the server, and some pre-verification. So all of that need to be true to allow committing to the main line. So our process now is more parallelized, and you can move between states. That's the reality of development. Things have to move freely from state to state. And now our Kanban tasks look like this. We have 7 parallel boxes to indicate the status of those individual steps. So analysis, documentation, test plan, test development, pre-verification, and the main card represents the code the state of the code. And all of them have to be green to let you merge stuff. So our Kanban states are reduced a lot. So you start from the backlog, you kick off the work, the team is assembled, you start developing iteratively, together, development, QE, in special branches, topic branches. You make pull requests, you do code reviews, then documentation still happens kind of outside the circle, and it can happen, at its own pace. We can add docs later if we're in a hurry. Feature is verified, and it's ready to go. So did this work? Well, we produced our first productized release with this system back in April. So we proved that you can do it. Next one comes, I think, in June. Or June, end of June, beginning of July. We simplified analysis. We put it on GitHub. It's on the PR, so it's easier to associate it with the code that goes with it. There's much better cooperation between engineering and QE. Regressions were reduced a lot. The magic rule of 7 was proven wrong for the first time, so I'm very glad about this. We only needed 2 extra builds to finish. So 7 to 2, huge improvement. There is some overhead, and some people complain about it, but I tell them, the alternative is to do Scrum. So, and they get it. And it still takes some time to go from community to product, something like 1.5 months. We think we can bring this down to about maybe a month. But since you have overlapping releases, after the first release, it doesn't matter much. So tooling. So when we started with this and we looked into what we can use, Jira has an Agile plugin that was very static, and initially when we had the many states, it was impossible to work with, and it was very slow as well. We looked at other tools. The problem is, if you use another tool, you have to synchronize with your main repository, lots of problems there, and you have to use both of them, so it didn't work quite well. So then we decided to develop our own plugin for Jira. We called it Jirban. And this plugin would go away with those limitations that we saw, would allow some key features like many states, collapsible tables, and many ways to filter, dynamic ways to filter, and speed. And that worked very well. I don't think we'll be able to do Kanban without this plugin. And we think it's so useful that we changed the name. We created a new open source project called Overboard. The guy is a Norwegian, so there's this funny dot over the A. And we invite people to use it. And it will look something like this. Let me see if I can switch to just to show you how this worked. So that's more or less the Agile plugin of Jira, right? So you can see that the items are squeezed. And you can scroll, you can scroll like this. And the problem is that filters are very static. If you have like 50 components, you have to set up 50 filters. And then if you want different swim lanes and all this stuff, it's impossible. So let's see if I can load Jirban. So I'm doing this over the phone, so let's see. Yeah. So the cool thing about this is it caches data both on the server side and the client side. So it's super fast. You can, go around, go left, go right, like this. You can collapse whole states, collapse the backlog. I can do arbitrary filtering. So let's say I want to see swim lane by component. Boom. What the various teams are working on. You can see all those, colored boxes. You can see things by assignee. I want to see what Farah is working now without this thing. So Farah, yeah, is developing a certificate authority integration, and I can see, all the blocker issues. I can apply arbitrary filtering, and it's instant because the data is cached on the client. So it's super fast. And then to configure this thing, let's say I go to this project that I showed to you. The cool thing is it works on top of an existing Jira project. You don't need to make something special to do your project. So there is some basic configuration to tell the tool, what are your states, which field to use to identify priorities, issue types, if you have any parallel tasks, and that's it. There is another view we call the rank view. So product management will go there and say, what's the relative priority of this item relative to this item? So they can change it. And the developer can go and look at their tasks, filter by their own tasks and say, I have to work on these items. And those are the states. So that's pretty useful. I don't think we would have succeeded without this small tool. And you install it on your Jira server, so there's no extra, you don't need to some external process or anything of that sort. And with that, just to wrap up.
Thank you, Dimitris.
Just this slide and I'm done. So Kanban can work with very complex projects with some tweaks. Kanban helps you focus on the way you work rather than on the process itself. You don't have to care too much about roles, ceremonies, and stuff like that. You need special tooling for sure, and I think planning is dead. When you work in very short iterations, it just doesn't matter. And it takes courage to do the right thing. The thing that you think is right. Yeah, maybe it's not the right thing, but and that's it.
Thank you for that, Dimitri. So questions from the crowd. We have 5 minutes for questions.
What makes more agile relative to the previous method? Well, the thing is, we don't have to commit on work. We pull work. So the developer will go there and say, I'm going to work on this high priority task. They will form a team, work the problem together, and when they're done, they would commit. There's no planning. Yeah?
Another question over here. Yep.
Hi. That was a great presentation. Thank you. My question is about estimations. You explained that you moved to time-boxed deliveries, and experience says that estimation trouble may arise. Did you have such difficulties, and how did you overcome them? Are you using some estimation techniques?
Yeah. Well, estimations are like huge topic. Yeah. So my boss was saying, well, I go to the mechanic to fix my car, and even the mechanic will say, it will take that much time to fix the car. So I told him how many times the mechanic is actually correct. He will just pull it, something idea out of his mind. And if he knows, if he's done it before, yeah, he might probably give you a good estimation. If he's never done it before, it's up in the air. Now, I assume if you get more serious with this stuff and then start collecting metrics, on average, I do so many things, and on this category, this component takes me, 3 weeks to move from inception to, code commit. Yeah, maybe you can do some better estimates. And so we prefer to do things abstract. So we put a release target and we say, who's going to work on this? What are the themes for this release? So we want to finish Java EE 8 and work on these 2 big initiatives and try to work the problem. We think we might make it, but maybe we won't. And when we moved to this process, the very interesting thing was that the same people that before they were insisting, you have to tell me when this will be over. Where are they gone? They disappeared. And no nose, is bleeding. No problem. So suddenly there's no need for that, right? So that was great actually. And we are able to move a lot faster. So imagine 18 months to 3 for a project that's like monsters. So I think that's good enough for me.
And time for one more question. Gentleman over there.
Hi, great presentation. My heart really goes out to you. We are going through a similar process right now, and I want to ask about task breakdown. During your analysis phase, how deep granularity do you define in your tasks, and how long within the process does this take?
Yeah. So how long the analysis phase takes? I don't know. It depends on the task. Some tasks are straightforward, and you need minimal investigation. Some other tasks might take a month. And because the whole process is asynchronous, so let's say you're the product manager, you put the request, I want clustering to be super fast. So, and then developers say, what's super fast? Send this back to like 50% faster, and compared to what? And they start asking questions. There is a dialogue. And if the PM cannot answer, well, tough. I'll move on to another task. I'll try to be productive in some other way. So it unblocks you from these situations. And my developers are, very experienced. Even if no one tells them, you have to do this, there's tons of stuff to work on. So there's not a matter of, staying idle or not working on priorities. And quite often, the engineers know better than product management what's needed for the project.
Thank you, Dimitri. A big round of applause before he gets off stage.